Hello, students. We are in 2.3 looking at homework. Let's see, I went through a few of these in a separate video. Let's kind of see here. Which ones do I think will probably be the biggest struggle? Shading tends to be an issue, so maybe we'll look at a few of the shading ones. The create your own Venn. If it's already done for you, I think that probably should be okay, but we'll have to take a look and see. We'll do one where we maybe build our own. Let's see. Find the simplest possible expression for A union C. Okay, so if you're looking through questions like this or defining whether things are always equal, yeah, sometimes you have to go back to the definition. What does it mean to be a set difference, right? So if I have a set A and I take out everything that's in A, what's remaining? There's no elements left, which means your set is now equivalent to the empty set. B, take a set difference A would be take B, remove everything that's in A. Okay, so I can picture that. Now take B intersect A if A is a subset of B. So maybe I even want to draw a picture for that one. Okay, so B intersect A if A is a subset of B. So if A is a subset of B, that means it's completely contained inside of B, and the intersection of A and B would just be everything here. So the answer for this one would be A, but over here it would be B without everything in A, which would be all the stuff that's kind of remaining out here even too. So no, these are not always equal. So the part C would be a no. Let's see here. What do we, if we had something like this, A union C. So A is the set of, since I don't know what they look like, plug in some values. 1, 2 times 1 is 2, minus 1 is 1. Plug in 2, 2 times 2 is 4, minus 1 is 3. Plug in 3, 3 times 2 is 6, minus 1 is 5, dot, dot, dot. Okay, so these are odd numbers. And B is 2 times the number. So those are even numbers. Okay. Let's see here. Part C, X is 2n plus 1, not minus 1. And n could be 0 or a natural number. So if it's 0, plug in 0. 2 times 0 is plus 1 is 1. Okay, so that takes care of that case. Now plug in 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. Oh, okay. So take a look. Actually, A and C look like they're the same. So A union C would just be A or C. Doesn't matter. It's the same set. A union B, that'd be all the odd ones together with all the even ones. So that would just be N. That'd be everything we have, all the natural numbers. And A intersect B, where do the odds intersect the evens? And you would say they don't. So the empty set. Be careful. Some of them will ask you for a counterexample, like here. If it's false, give a counterexample. All you have to do for a counterexample is build a single set example. So as to kind of demonstrate that, if you were doing part B and you're saying A set difference B is equal to B set difference A, that's like a student says that to you. You would say, okay, let's take a look. I'll say that set A is the set 1, 5, 9. And B is the set 3, 4, 5. Okay. So then A set difference B is everything that's in A that's not in B. So that would be a 1 and a 9. But B set difference A is everything that's in B that's not in A. So that would be 3 and 4. And now you're kind of saying, hey, look, these two right here, they're not the same. So that would be your counterexample. So you'd say false, and here's your counterexample. That's how you could demonstrate that something is false. Just give one counterexample. Let's see here. Here we say shade the portion of the Venn diagram that illustrates the set. If I was doing this, if I was like had my own homework, I'd have like a sample one, like my practice part, and then my final. Okay. So if I was doing that, and I came to the first one, it says A intersect B. Here's A, B, C. A intersect B. Okay, so where does A and B intersect? That's right here. Okay, that's A intersect B. And then A intersect C. Okay, I'll choose a different color for that. So why don't I choose yellow for A intersect C. So that would be this region right here. Okay. Okay, so there's that. And then I want the union of those. So that means you can be in one or the other or both. If you want to use the language I tend to use in class, you would say at least one of those. And so my final answer here would be that you could be in any part of this shaded region right here. All right. And if you came back, what if the symbol in the middle was an intersection? Well, then you would look and see, where do those actually intersect? Where does green and yellow intersect? Because you got to be in both. And then you would only shade this region because that's where those intersect. All right. If you do have one that's like a complement, just remember a complement is everything that is outside or not included in. So if we want to do that one more time, A union B would be anything that's in A or B, including the region in the middle. So there's A union B. Then shade everything that is not in C. And that means everything that's not in C. So definitely the stuff inside the box, but also all of this other stuff as well, right? So when you shade, you need to make sure you shade everything that's not in C. And then look at what is it asking you to find. Here it says we're trying to find the intersection. So where does yellow and green intersect? Okay. So I would, for my final answer, because I've just shaded these to help myself see where everything is, my final answer would be where those two overlap. So that would be everything in this region. Okay, because it has to be in A or B. That's at least one of those. And it cannot be in C. And that's the thought process when you come down and start kind of labeling them yourself. When you're doing this, like down in the older one, you kind of actually put your own set notation on it. You have a lot of things you could look at. You could say, well, here's A or B. Here's the union. And it's like, I want everything that's not in there. So just write that. Take A union B and throw a complement on it. Put everything outside of that. Over here, you could say this is everything that's in B, because it is definitely in B, and it can't be in A, and not A. So there's B and not A. If you wanted, you could also do B, but take out everything that's in A. That's fine too. These are equal. Okay, so more than one way to write these and be perfectly correct. Let's see here. There's another one up here. So this would be A. It has to be in A, and it's in B, and it's not in C. The goal of doing all that stuff with the physical hands-on is to help you say, wait a minute, earlier I had red and triangle and small. So if you had something up here, you'd say it's red and it's a triangle and it's not small. Well, just when you turn that into set notation, all you have to do is say, okay, well, it's A and B and not C. And that's it. There's your set notation for that. Okay. Let's see here. Then we have a shading piece. This says, again, if you read it, sometimes it's actually not too bad if you just read it. This says not in A and in B. Okay. So it can't be in A and it has to be in B. Got it. Okay. It's got to be in B and it can't be in A. So that must be my piece right there. That's it. Then it says, what's another expression for this? Well, you could say, well, I could write B and not A, or you could write B and then take out everything that's in A. That's the same pieces. All right. I think that's about it. If A has 3 elements and B has 2 elements, what's the greatest number possible here? What's the least amount possible here? All right. Now those are interesting because remember if A has 3 elements, like it says 3 elements, then there's 3 things total in A. If B has 2 elements, then you could say, well, wait a minute, the most they could have in common is 2, and then there'd be 0 here and 1 here to make a 3 in A and 2 in B. So that'd be the maximum. Okay. Now, if you take a look at the union here, the union would only have 3 elements in it, right? The number in A union B is 3. But what if you go back and you say, well, wait a minute, what if I consider that maybe they don't have anything in common, right? Maybe these 3 objects over here have nothing in common with the 2 over there. Now, all of a sudden, the number in the union is 5. So you can see there is a difference here, right? The difference is sometimes that intersection doesn't have anything in it. So if you want the union to be big, you need to make the intersection very small. If you want the intersection to be big, right? A lot of things in the intersection, the amount in the union has to go down in order to make that happen. And that again comes from the activity we did in class with the colored shapes. We came up with a really nice way of relating these, that the number of things in A plus the number of things in B minus the number that are in the intersection, because we didn't want to double count, is going to be the number of things that are in the union. So if you know how much is in A and you know how much is in B, if you have a lot of stuff in the intersection, that means you're subtracting more that is being double counted. The amount in the union is going to go down. So if one goes up, the other has to go down. Okay. That's a nice little connection there between those ideas. Oh, let's see here. There's one with the how many non-Democrats? Well, just put your thumb over the Democrat piece and say, well, there's looks like 18 were not Democrats. Okay. Was there anything else from this one? Sorority with 40 members, 18 take math, 5 take math and biology, 5 take neither math nor biology. How many take biology but not math? Okay, so once again, there's a little, a little piece here. In a bicycle shop, 50 bikes were inspected, 20 needed new tires, 30 needed gear repairs. What's the greatest number that could have needed both? So again, this is just like basically this is a word version of what we just talked about. Well, the most that need both have to have both tires and gears. So the most would be 20 because there were only 20 that needed new tires. Okay. What's the least amount that could have needed both? Well, if there were 50 total bikes, is it possible to have 20 that needed tires, 30 that needed gears, and nothing in the middle? And the answer is, yeah, that's possible. If everybody who came in needed just tires or gear repair. So if you kind of draw the picture out, you can put 20 in one side, 30 in the other, 0 in the intersection, and just make sure you still get the 50. Okay. So for like a test, I could see myself maybe changing this to like a 40. Why wouldn't I? What if there were only 40 bicycles that were inspected? 30 needed gear repairs and 20 needed new tires. Well, that right away tells you, right, there had to be some of both. Like there had to be. Doesn't tell you how many, but there had to be some of both. Let's see here. Okay, so A, B, R, H. Okay. So there's one. What else do we have here? John, registrar's office. He did have 100 students, 45 take math, 45 chemistry, 45 physics, 20 take math and chemistry, physics and chemistry, take math and physics, all 3 of the subjects. Yeah, this is one where, once again, if you're if you're doing a problem like this, try to find the pieces that work for everything, right? Find the big ones, and then you work your way back down. So if I was doing this one, let's see how good I can do on my circles here. Whee, okay. Yeah, not bad. Not bad. All right, that looks good enough. I'm gonna stop while I'm ahead. All right, so let's see here. What do we know if we do problem 22? Well, I know 8 people take all 3 subjects. What are my subjects? I have math, chemistry, and physics, okay? 8 take all 3, so I'll put the 8 in the middle. Okay, that takes care of that one. And then it says what? 10 people take none of the subjects. Okay, so it's 10 sitting out here, right? Okay, 10 take math and physics. Well, math and physics would be this whole eyeball shape here, but I've already used up 8, so there must be 2 because 10 took math and physics. Okay, that takes care of that. 15 took chemistry and physics. Once again, I've already got 8, so there must be 7 there to make 15 total. Let's see here. And 20 take math and chemistry. So math and chemistry 20. I already used up 8, so that'd be 12. And now let's see what it says. 45 take mathematics. So mathematics is 45. So right here, 8 and 12 is 20. Plus the other 2 over here is 22. So that leaves 23 for taking mathematics, but not the others. Let's see here. 40 take chemistry. So again, I've got 27 here. So that'd be 13 taking chemistry out there. Chemistry, but not math and physics. 47 take physics. That's 10, 17. So that'd be 30 that take physics right there. All right. So there we are. Now, let's see here. We know there's supposed to be 100 students. I guess that's maybe what I would do next is just make sure if I add everything up, do I get 100 students total? So like right here, 47 take physics. So if I was doing this, I'd be like, okay, there's 47 plus another 10. That's 57, right? That's 57. 67, 77, that'd be 80. A 10 here is 90. There's 105. So I got 105. He said he did the survey of 100 students. I'd be like, something happened here. Something happened, John. I don't know what happened, but it doesn't match. All right. So there we go. Let's see here, 2.3, very similar questions, very similar questions. I'm pretty sure I did one with 5 and 7. I think were the questions I did on that one. All right. And that's about it here. 100,000 RH. Yeah, so these are very similar. Survey of 150, 90 algebra, 30 taking biology. What's the smallest number that could be taking both? What's the greatest number that could be taking both? So again, very similar to what we've talked about in the other questions. This is the one we started doing in class. I didn't work through the whole thing. Some people did say, hey, it'd be nice. Can you kind of show what would be the idea for the whole thing? So I could do that. Throw some white space in here. Get my grid going. So here we go. Again, your labels could be different than mine, and we could still get exactly the same information. So don't freak out if our labels are different. The concept will be the same, and we'll still be able to answer all the same questions. Okay, so I need, what do I want to say here? I need something like Canadian or American. So I'm going to put Canadian here. So this will be my Canadian circle. Then I need male and female. So I'm going to say female, I guess. Okay, there's the female one. And what else do I know? Adult. Okay, so adult or child. So if we were labeling these using what I would say is more traditional gender norms, because again, this is a type of question we'd have to be a little bit more cautious with. So if I was looking at each little space, I could take a look here. So this space would be someone who's Canadian, not female, so that'd be male, not adult, so that would be like a Canadian boy. Okay, so male, not adult. All right. And likewise, if we came over here, this would be, okay, so take a look. It's female and adult. So based on the language from the past, we would say woman, but not Canadian. So that'd be an American woman. Okay. So what do I know? I know there's 17 American women. So that's helpful because now I can go and put 17 into that spot. Okay. Let's see here. Canadian female. So there's 26 Canadian females. Okay, so these two together is 26. I'll just put that temporarily because I do want to get rid of that because I want a number in each one of these spots if at all possible. Yeah, 29 girls, 29 women. Okay, girls and women, that would give me the total. So 29 plus 29 would give me 58, and that would be 58 females. Okay, so if I have 58 females total in the whole female circle, there's 26 of them in that Canadian chunk, right? So if I take away 26, that leaves me with 32 American females. And I've already used up 17 because out of the females, 17 were American women. So that leaves me with 15 is what I would put right there. Okay. All right. So that means what else? The 17 American women clue. I don't think I can use that one for anything else. Okay. What else do we have here? 44 Canadian citizens and 24 Canadian adults. Okay. And what else? 17 American males. So, 17 American males. So American males would be not in Canadian, not in female, and they'd have to be adults or not. Doesn't say. So again, these two spots right here is worth 17. And I wish I knew more about those two. So I'm not sure how those numbers are split. 44 are Canadian citizens. So there's 44 Canadian citizens. Actually, they're just asking us to find the total number of people in the group. So if there's 44 Canadian citizens, then this entire Canadian piece right here is worth, kind of circle all of it there, right? All of this is worth 44. Okay. I've got 17 American males, 32 American females. So I have 44. I have 32, and I have 17. So those are the three little chunks. All Canadians are covered because I have this many Canadian citizens. And the American males could be adult or not. I don't know. There's 17 of those. Yeah, so I think that works. Let's see here. So I have 4, 5, 6, and 7 is 13. 4, 5, 6, 7, 8, 9. So I end up with 93 people in the group. And in this case, doesn't look like there's enough information for me to figure out how many are in each subcategory. But that's all I need. So there we are. Awesome. I am going to call that good. I'll come back with Math Connections 2.3 and see if there's any other additional issues with that one. That's it for now. Off you go.